Hi everyone, I'm Rongzhen, a student from Dresden University of Technology. It's a great pleasure for me to shortly present the post of our paper titled Automatic Detection of Voltage Notches Using Support Vector Machine. Voltage notch is a common power quality disturbance in industrial power systems. It is a periodic voltage reduction caused by the commutation of controlled line commutating rectifiers. However, the conventional manual inspection, which is visually implemented by utilities, is difficult and time-consuming. In recent years, highly automated artificial intelligence methods have rapidly developed and have been applied to automatic detection and classification of different PQ disturbances in PQ measurements and monitoring. The main task of this work is develop an automatic method for notch detection and classification. There are four main objectives. First is development of a nonlinear SVM-based framework for analysis and detection. Then, the conduction of systematic simulations for different PQ disturbances for comprehensive data generation. The third is the development of an efficient method for automatic notch detection. And finally, classification of notch from other PQ disturbances. To get a diverse dataset, we have conducted a systematic simulation on MATLAB. 5 types of PQ disturbances are simulated, considering their characteristics and frequency of occurrence in power system. And for notches, 3 types of notch sources and 4 groups of influencing factors or components were considered. Additionally, 71 examples of notch from field measurements were added in the dataset. Finally, 1,311 samples of PQ disturbances were generated as dataset for machine learning. This figure is an example for the simulation data. The first is a waveform of notches from a snubber circuit, and the second figure is notches with capacitor banks. We can see they are much different from each other. The methodology has 2 layers. The outer layer is a 5-fold cross-validation. The inner layer, or we can say each pass of the cross-validation, includes feature extraction, feature selection, and parameter tuning. 14 features were extracted from the original time series data and the deviation time series data. The deviation time series is created by subtracting the fundamental wave from the original time series. The 2 types of time series were firstly transformed by probability density function, phase reconstruction, and fast Fourier transform. And then features were extracted from the transformed data. For feature selection, we applied decision tree, and the hyperparameter tuning was implemented by grid search. As mentioned, the outer layer of the methodology is a 5-fold cross-validation. After that, the optima features and SVM model were selected. The optima features are the 23rd harmonic, the total harmonic distortion, and the sample entropy. The selected SVM classifier has achieved an accuracy of 98.5% for the validation data. And finally, the method was applied. It has achieved a total accuracy of 99.2% for the testing data. Among all the samples in testing data, only 3 non-notch and 2 notch samples were misclassified. When we look one step further into the misclassified examples, we found that the misclassified non-notches are swells with accompanying impulsive transient of capacitor bank, and the misclassified notches are from M3 rectifiers whose depth is lower compared to correctly classified notches. As can be seen in this figure, in the feature space, the points of misclassified samples located in the overlapping area. This paper proposes a comprehensive framework for simulation of notching phenomena and automatic detection based on nonlinear SVM classifier. According to the results of the method performance, the feature extraction based on both domain knowledge and time series properties, together with the feature selection algorithm, such as decision tree, can highly reduce the feature vectors, decreasing the risk of overfitting and at the same time saving considerable memory space and computation time. Furthermore, the constructed classifier can classify notch and non-notch waveforms with high accuracy of 99.2%. In the future work, several potential improvements can be done for the notch detection and classification, for example, localization of notch source and application of multi-class SVM to a more diverse database of PQ disturbances. That's all for my report. Thanks for your attention, and I'm happy for any questions.